is lesson 9.4, dealing with changes in dimension. So, for our warm-up, Mr. Tennant is building a doghouse that is 4 feet long and 2 feet wide. So I want you guys to find the area and the perimeter. What did you get for the area, Alinza? Perfect, so we get an area of 8. And what about our perimeter, Jenna? Perfect, we get a perimeter of 12. As we know with our area, it is base times height and or length times width. For perimeter, it is 2 times the length plus the width. It's 2 times the length plus the width and or base and the height. They are the exact same thing. We just called them different stuff. So it is 2 times the base plus the height. Elsie was saying it distributive property style, which is the exact same thing. She said 2 times the base plus 2 times the height. All she did was she distributed that 2 out to each of them. This way, the 2 times base plus height is the factored form of the way. So either way works. Now, Mr. Tennant decides he wants it bigger on the inside, and he doubles the width. So if our old dimensions were 4 feet long and 2 feet wide, and he doubles the width, what are our new dimensions? What are our new dimensions? What is it, Daniel? What's our new dimensions? If it's 4 feet long and 2 feet wide, what are the new dimensions we're dealing with? We doubled the width. What is our new dimensions? So our length is still 4, but what is our width now, Daniel? It's 4. So our new area is 16. And what about our perimeter? What's our perimeter, Gore? It's also 16. Remember, it doesn't always have to be the same. It doesn't end up always being the same. But the area became what? What happened to that area? What happened, Hannah? It doubled. The same way that we doubled the width, our area doubled. We doubled one of the sides, so our area doubled. So our area doubled. As opposed to the perimeter, we got 4 bigger, which is 2 times our original thing. Does not matter. Now, changes in effect of perimeter. Hold on. And the perimeter, what it changed is we now are doubled what the width was. We added to it, WIDTH. So we added that on because now it's 4 more. Our perimeter is 4 more, which is now what this new one is, 4, because we've added 2 to each of those sides. We've doubled each of those. So, changes in effect on perimeter. If the dimensions of a polygon are multiplied by x, then the perimeter of the polygon changes by that factor of x. So, if all of my dimensions are changed, if I doubled it, so I moved this here and I doubled this entire triangle. I've got sides 3, 3, and 2, doubled the whole thing. It is now 6, 6, and 4. My perimeter of the first one was 8. My perimeter of the second one is 16. I doubled the first one, so the change is that it's doubled. This is the important part. If the dimensions of a polygon are multiplied by x, the perimeter of the polygon changes by a factor of x. A polygon, by the way, is any 2D shape made with straight lines. So it is not 3-dimensional, and it is not a circle or with circly parts. So first I want you to find the area. Actually, I don't want you to find the area. I want you to find the perimeter of this shape. So what's the perimeter of this first shape? What's the perimeter, Rocco? 14, excellent. We just added 4 plus 4 is 8, 3 plus 3 is 6. We add them together. Or 4 plus 3 is 7 times 2 is 14. Many ways to go about it. Then we're multiplying each of the sides by 3. This new side is going to be 12. 4 times 3 is 12. And this other side is going to be 9. What's my new perimeter now? What's my new perimeter now, Ben? Our new perimeter is 42. How do these two relate? How do 14 and 42 relate as a ratio? 14 and 42 relate as a ratio. Gore?
14 is ordered pairs. 14 is 1 and 42 is 3.
Yes, as a ratio, or as you said, the ordered pairs, which is great. It's 1 to 3. It's 1 to 3. So these would be a linear line. As we know, when we would be drawing it, if we start here, it's 1, 3, we'd still end up here at 14, 42. It'd still make our nice line. It is going up by a factor times 3. So it is just 3 times as big as the other one. So if I divide the sides by 2, what effect does it have on the perimeter? With triangles, our perimeter isn't 2 times the base and times the height and all of that because we don't have that. We just got to go around it. It's called perimeter because you are walking around it, the meters, like as if you're walking, blah, blah, blah. Now, we get this. What's the perimeter of this shape, Rafi? You know, I'm going to make our lives all easier because I made it weird numbers. So instead, we're going to make it 6, 8, and 20, just to make our lives a little easier. So, Miles, what do you get?
17.
So, Ben, what is the perimeter? We get our perimeter being 34. So our original perimeter is 34. So if I divide the sides by 2, what effect does it have on the perimeter? My new sides are now 3, 4, and 10, which gives us what Miles said of 17. And what is the correlation between 17 and 34? Hannah?
17 plus 17 is 34.
Exactly. 17 plus 17 is 34. So it's 1 to 2. Our ratio is 1 to 2. What's your question, Elsie?
The question is, so basically, whenever, like, let's just say in that example, to find not the original perimeter.
She says to find the new perimeter, you just double it. We follow the instructions. So this one says divide sides by 2. Some of them might say multiply by 3. Some of them might say any sort of thing. But as we know, it's always going to be with multiplication or division because we're keeping these as ratios. As ratios, they can only be done with multiplication or division. Because if I tried to do it with addition and subtraction, here I'd be subtracting 16. But here I'm subtracting 32. Those aren't subtracting the same thing. So it has to be done with multiplication division. Here's the last one. If the dimensions of a polygon are multiplied by x, then the area of the polygon changes by x times x or x squared. As such, what is the area of figure 1, Adriana? Perfect, it's 20. And what's the area of figure 2, Michelle? Perfect, it's 80. And as we see, what we did here to go from 5 to 10, we doubled it. So our dimensions are going to be times 2 times 2 because it's x times x. 2 times 2 is 4. And how do I get from 20 to 80? Times 4. So when we are multiplying this, our figure is going to be going up by our increased ratio squared. So what about here? What's my area for this first one? What's my area for the first one, Malia? 10. The sides are multiplied by 5. What effect does it have on the area? If my sides are multiplied by 5, what are my new sides then? Matthew. Noah. So then what are my new sides then, Jaden? Hannah. My new sides are 10 and 25. So what would my new area be then, Matthew? 250. Excellent. So I went here times 5. 2 times 5 is 10. I went here times 5. 5 times 5 is 25 because I multiplied the sides by 5. But what effect did that have on the area? What effect did that have on the area? How much bigger did it get, Hannah? Yeah, it was multiplied by 25, which, as we see here, is 5 times 5. X times X. 5 times 5. So, if I multiplied my shape, if I multiplied the sides by 3, my figure would increase in area times 9, because that's 3 times 3. So who could wager a guess of if I multiplied my sides of a shape, here is my shape, and I multiply it by 12. I multiply all the sides by 12. How much do you think my area is going to increase by? How much is my area going to increase by? Michelle? Not by 12. By what, Rocco? Not by 11. What is it going to increase by, Daniel? 144. Yes. And here's the proof. Here's the proof. If I multiplied each side by 12, from 1 to 12, that's 12. From 1 to 12, that's 12. The area of my first shape is 1. The area of my second shape is 144, which means I've gone 1 to 144. That's 1 times 144, which that's the same as 12 times 12, or 12 squared. And the reason it happens is because I'm multiplying it by 12 on one side and 12 on the other. The way we find it is by multiplying sides. So Rocco said, didn't it go up by 143? We started at 1 and we're now at 144. As I said on the last slides, it can only work with multiplication. Ratios only work with multiplication. We're not doing addition or subtraction. We only do multiplication or division because they are ratios. Just like when we did our ratio tables and we saw this, if I had this as my ratio table, 1 to 3, 2 to 6, 3, I'm not just going to be adding another whatever. Actually, that's a bad example.
I get it.
If I had this, if I had 2 to, 1 to 4, 2, whatever, it's not the point. The point is that it's always by multiplication, not by addition, or in division, not by division and subtraction. Blah, blah, blah. So, here, the sides are multiplied by 2.5. If each of my sides are going to be multiplied by 2.5, then my area is going to be multiplied by what? If both of my sides are going to be multiplied by 2.5, what is my area going to be multiplied by, Ben? By what?
No, by 5.
Not by 5. That's just adding. By what? 6.25. Yes, because that is 2.5 times 2.5. 5 times 5 is 5. 5 times is 25. 5 times 2 is 10. We get 12. Magic 0. 2 times 5 is 10. 2 times 2, we get our 5 there. 5, 2, 6. 6, 2, 5. So it's multiplied by that squared, or that times that. Now, I want you to go to page 700. We're going to do number 3 and the guided practice 1 through 3. A stop sign is in the shape of a regular octagon. Sign A shown at the right has an area of 309 square inches. So what is the area of sign B? It's wanting to know how we went from 8 to 12. This again is how we kind of use our function charts. It actually does work. If 8 to get to 12, if 8 is our 1, I can't go to 12 immediately, but what they do share is a 4. That's going to be dividing by 2. So I divide this side by 2. I get 0.5. Then to get from 4 to 12, I multiply by 3. I multiply by 3, I get 1.5. So 8 times 1.5 is 12. 1.5 times 1.5 is going to be equal to 2.25. You can trust me. You can do the math later. I'm not doing it. Here it is actually right there. And then you just multiply it by the original area. So once you find out how much you're increasing a side by, that's how much you multiply the area by. Or once you know how much you're increasing the side by, that's when you find the area. You're able to use any of the pieces to do that. Gore, each side length is doubled. Describe the change in the perimeter. What is the change in my perimeter if each side length is doubled? And we have that drawing over there. I didn't put it here. We've got this. It's 4, 5, and 6.4. So when I double it, what happens to my perimeter? My perimeter becomes what? What's the factor that's affecting my perimeter? Ben?
It becomes bigger times 4.
So it becomes bigger times 2 because it's perimeter. So it changes by the exact same amount. The sides are doubled, then the amount is doubled. But what about this one? Each side length is tripled. What's the change in the area, Michelle?
I got the area multiplied by 9.
Yeah, by 9 or by 3 squared. Your homework is page 701, numbers 1 through 6.